Assalamualaikum class. Are you guys ready for today's lesson?
Waalaikumsalam.
Ready,
Yes,
teacher.
ready.
If you guys ready, let's get started. Last class, we have learned about the development of atomic model. So today, based on this first page of my slide, what do you guys think we want to learn about?
Proton and electron, I think.
It's right.
So today, we will learn about atomic structure. So now you can refer your textbook, page 32. Okay, first of all, I will share the learning outcome of the topic. Okay, at the end of the lesson, students are able to define proton number and neutron number, determine the neutron number, proton number, and also number of electrons in an atom, write the standard representation of an atom, and lastly, construct an atomic structure diagram and electron arrangement. Next, the educational emphasis. Two of my students can differentiate between number of proton, number of electron, number of neutron, and neutron number. 3 students can calculate the proton number of neutron, and neutron number. 2 students can write an element notation of any element. And lastly, 2 students can draw the electron arrangement and also the atomic structure of an element. Okay. So, Adina, do you have any idea about atomic structure? What can you imagine about atomic structure?
Atomic structure is when an atom have proton, electron, and neutron in the nucleus.
Okay, you are correct. So now I want to show you a video about atomic structure.
To describe and count the number of protons, neutrons, and electrons, scientists use the terms atomic number and mass number. Look at this bowl of apples and pears. Can you count the number of apples in the bowl? What about the sum of apples and pears? Now, imagine the bowl of fruits as the nucleus of an atom, and the apples and pears as the protons and neutrons. Imagine that the apples are protons. If you know the number of protons, you know the atomic number. The atomic number is the number of protons in the nucleus of an atom. It is denoted by capital Z. Each element has its own atomic number, and because the atomic number is unique to each element, it serves as a tool to identify elements. Take hydrogen, for example, with only one proton in its nucleus. So, its atomic number is also 1. No other element has an atomic number of 1. Carbon has 6 protons. So, its atomic number is 6. If the atomic number of an element is 6, then that element must be carbon and nothing else. Now, the atomic number also tells us the number of electrons. You know why? Correct. Remember when we asked you about the sum of apples and pears in the bowl? Now that the apples and pears have become protons and neutrons, the sum of these protons and neutrons is the mass number. Mass number is the sum of protons and neutrons present in the nucleus of an atom. It is denoted by capital A. Since the protons and neutrons are also called the nucleons, the mass number is also called the nucleon number. Unlike the atomic number, the mass number is not unique. Look, hydrogen always has the atomic number of 1, but its mass number could be 1, 2, or 3. The different mass numbers are due to different number of neutrons in the nucleus. The more neutrons there are, the higher the mass number. Therefore, we cannot identify the atom based on the mass number. Mass number equals the atomic number plus number of neutrons. The neutron number is denoted by a capital N. So, A is equal to Z plus N is the formula for calculating the mass number. If we know the mass number and atomic number, we can calculate the number of neutrons in an element. Number of neutrons equals the mass number minus the atomic number. So, N is equal to A minus Z. Let's look at some examples. Hydrogen has 1 proton and 0 neutrons. 1 plus 0 is equal to 1. So, the mass number of this hydrogen atom is 1. Carbon has 6 protons and 6 neutrons. 6 plus 6 is equal to 12. So, the mass number of carbon is 12. This is the notation of element carbon with its symbol, atomic number, and mass number. C is the symbol of carbon. 12 is the mass number and 6 is the atomic number. The general notation is a capital X, where X is any element. A is at the top left, where A is the mass number. Z is at the bottom left, where Z is the atomic number. Let's do a quick activity. Pause the video and discuss. A is wrong since generally the mass number is greater. B is wrong since in hydrogen, the mass number is equal to atomic number. D is wrong because it is the mass number that tells us about the number of protons and neutrons. C is correct because the atomic number tells us both the number of protons and electrons, as an atom has an equal number of both. Today, we learned that the atomic number Z is the number of protons in an atom. The atomic number is unique for every element. The mass number A is the sum of protons and neutrons in an atom. The formula to calculate mass number is mass number A equals to atomic number Z plus number of neutrons N.
So, as Adina said, an atom has the subatomic particles, which is protons, electrons, and neutrons. Now, we will start with the definitions of number of protons, number of neutrons, and also nucleon number. So, Howard, what is the difference between number of protons and proton number?
There is no different, teacher. They both are the same thing.
Yes, the number of protons in the nucleus of an atom is known as the proton number. For example, the number of protons for oxygen is 8. The number of protons for sodium is 11, and for chlorine is 17. Where you can find the answer, you can refer to the periodic table. So, Duha, what is the proton number of calcium? Here is my periodic table. The top one is the proton number. So, Duha, can you tell me what is the proton number of calcium?
Yes, teacher. 20. Is it correct, teacher?
Yes. That's correct. Okay. So now we continue with the number of neutrons. The number of electrons is equal to the number of protons. So to find the number of neutrons, subtract the proton number from the neutron number. For example, the number of neutrons for oxygen is 8, sodium is 12, and chlorine is 18. Next is neutron number, the total number of protons and number of neutrons in the nucleus of an atom. So this is how we want to find neutron number of protons plus number of neutrons. So for example here, we want to find the neutron number of oxygen. The proton number of oxygen is 8 and the number of neutrons for oxygen is also 8. So 8 plus 8 is equal to 16. Neutron number of oxygen is equal to 16. Okay, another example, let's take a look at your textbook, page 33. And the question is, the neutron number of a potassium atom is 39. So they given the neutron number, which is 39. A potassium atom has 19 protons. The number of protons also given, which is 19. How many neutrons and electrons are there in a potassium atom? So you have to find the neutron and electron. As you know that number of electrons is equals to the number of protons. So the number of protons given is 19. So the number of electrons is equal to 19. So now we want to find the number of neutrons. We have to subtract the number of protons from nuclear number. So 39 minus 19 is equal to 20. Okay, the number of electrons is same with the number of protons when the atom is neutral. But what if the atom accepts an electron? May I know the answer from Shohada?
Yes, teacher.
What happens if an atom accepts an electron?
I think the atom will become an ion.
Yes, very good, Shada. Very good. If the atom accepts the electron, and it will call an ion, and if it lost a electron, and it will call cation. So this is a table that shows us the subatomic particles of chlorine atom and chloride ion. Okay. The number of protons for chlorine atom and chloride ion is same, which is 17. The number of neutrons for chlorine atom and chloride ion is 18. But for the number of electrons for chlorine atom is 17 and the chloride ion is 18. Okay, a chlorine atom accepts one electron to form a chloride ion. So the chloride ion has one electron more than the chlorine atom. The number of protons and neutrons in the chloride ion and chlorine atom remain the same. Okay. Therefore, during the formation of ion from an atom, the number of protons and the number of neutrons in the nucleus remain the same. Okay. Have you guys seen this before?
Yes.
Yes. You guys already seen it in the video, right? So the X here is represent the symbol of an element. A here is represent the mass number, which is proton plus neutron, which also equals to the nuclear number. And last one, Z here is represent for atomic number or proton number. Okay. Shuhada, can you tell us what element is this?
This is a phosphorus element.
What is the neutron number of the element?
The neutron number is 16.
Yes, very good. Just minus the 31 with the 15. Okay. Now, Duha, what is the next element?
Yes, teacher. The next element is nitrogen.
Yes. And what is the electron number of the element?
Electron. 7.
Yes. That's the correct answer because the electron number is equal to the proton number in the nucleus. Okay. Now we continue with the atomic structure and electron arrangement. Okay, the number of maximum electron in the first three shells for element with proton numbers 1 to 20. Just like this figure, the first shell just fit two electrons, and the second shell only filled with 8 electrons, and the third one is also filled with 8 electrons, and so on for fifth shell. Okay, the outermost shell filled with electrons is the valence shell. So here the valence shell is the third shell. Okay, and the electron in the valence shell are known as the valence electron. So in the valence shell, there are 8 electrons. So the valence electron is 8. Okay. The chemical properties of an element depends on the number of valence electrons of an atom. So the same number of valence electrons, so the elements are having the same chemical properties. Okay. So this is an example for atomic structure and also electron arrangement for aluminium. Let me show you how to draw it. Okay, here. Okay, we have to know the proton number for aluminium. Aluminium is 13, right? We have 13 protons. So we have to draw first. We have to draw the nucleus. We have to draw the nucleus first, and then the first shell, which is filled with only two electrons. And next shell, the second shell will fill with 8. Are you guys with me?
Yes, teacher.
Yes, teacher.
Okay. So the remain electron is 3. So we have to add another shell, the last shell, the outermost shell, and put it 3. 1, 2, and also 3. Okay. So this electron arrangement, we have to put it here. So if you want to draw the atomic structure, the question wants you to draw the atomic structure, then you have to put the number of protons and neutrons in the nucleus. Okay?
Okay, teacher.
Here I put it here. Then the T. Neutron, neutron. It's not nucleon. You have to put the neutron. So nucleon minus the proton. Okay. 27. Sorry, my handwriting is very bad. 13 is equal to 14. 14 neutron. This is how you want to draw the atomic structure. Okay. And this is the electron arrangement. So it also can be written as 2, 8, 3. And this is the valence electron. Okay, now I want Howard to draw a potassium electron arrangement, and Shahada, you have to draw magnesium atomic structure. Can you do that?
Yes, teacher.
Okay.
I will try.
You can join my board here. Here, I have to do. Okay, can start drawing now.
Okay, teacher.
Where are you? I cannot see the drawing. I can see Shahada.
Teacher, my drawing is below your drawing.
Okay.
I made a tiny circle only. Wait a minute, okay?
Okay. Take your time. Okay, Howard is already finished her drawing.
Yes, teacher, I'm done.
Okay, the drawing is very good. Very neat than mine.
Thank you, teacher.
I'm done too.
Haga, okay, your drawing is also drawn perfectly. Okay, you guys are very concentrate in my class. So now, now I have prepared a pop quiz for you guys. So you have to complete it by midnight. Is that fine with you guys?
Yes, teacher.
Okay, teacher.
If
Yes,
that's
teacher.
fine, you may submit it and I will create a folder. So now I want Adlina, can you conclude what we have learned today?
Can, teacher. So what we have learned today is about proton number, number of neutron, and nuclear number of an atom. Also, we have learned to write the standard representation of an element, which also known as the notation of an element. And lastly, we also learn how to draw the atomic structure and electron arrangement of an atom.
Yes, very good. Today's topic is very simple, right? So that's all for today's lesson. See you next class.
See you next class,
Okay.
teacher.
Thank you, teacher.
Thank you.
Okay,
Thank you, teacher.
bye.